My name is and I'm the Executive Editor for Dataversity. We would like to thank you for joining today's Dataversity webinar, Unlock Business Value Through Data Quality and Engineering. This year's June edition in a monthly series called Data Ed Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. Now, give the floor to Eileen Berkowitz, the webinar organizer from Data Blueprint, to introduce our speaker and today's webinar. Eileen.
Great. Thank you so much, Shannon. Hi, and welcome, everyone. We're so excited, as Shannon mentioned, that you have found the time to join us today. Thank you, as always, to Shannon and Dataversity for hosting us every month with our webinar series. We'll get started in just a few moments after I introduce your speaker and also let you know some housekeeping items to let you know what to expect. As usual, we're planning 1 hour for the presentation, and then you will have 30 minutes to ask your questions and make general comments. Try to answer as many questions as time allows at the end. To kind of just think of a question as you see Peter present. So feel free to just submit them through the chat as you can think of them throughout the session, and I'll keep track of them. And some of the questions that we get asked most often, you will receive an email with the link to download today's materials and any other information you request within the next 2 business days. And it's recorded, so you'll get everything from today's session. Also, you can find us if you have any questions on Twitter and Facebook. We've set up the hashtag Data Ed on Twitter, so if you're logged on, feel free to use it in your tweets and also submit any questions or comments you have that way. Now, let me introduce you to our speaker. Many of you probably already know of or have met Dr. Peter Aiken. He's an internationally recognized thought leader in the data management field, and he speaks and presents at conferences nationally and worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions. He is also the founder director of Data Blueprint, our company, as well as the current president of DAMA International. To date, Peter has written 8 books and of articles. The most recent book is just hot off the presses. It was released in April, and it's a topic of the need for why we need a chief data officer today. It's a very, very interesting topic going on right now, and the best way to get yourself a copy is through Dataversity's new bookstore. You'll receive more information on how to do that in the follow-up emails after the event. And so back to Peter. He's experienced more than 500 data management practices in 20 countries and consistently named as one of the top 10 data management experts in the world. He has spent multi-year immersions with organizations as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Fargo, the Commonwealth of Virginia, and many more. He is often requested at conferences and workshops and is always traveling to numerous speaking engagements. So Peter, usually we have to ask you where you are, but I know where you are today.
Yeah, very happy to be in the new office space for Data Blueprint. We've doubled our square footage size, so I guess that's a good thing coming out of the session. Welcome, everybody. Today's topic, unlocking business value through data quality engineering. As always, I want to acknowledge the Virginia Commonwealth School of Business, where I'm a professor there as well. Let's right into the material and take a look at what we're going to do today. First of all, I always start out these seminars with a data management overview to give you some context on where we fit in. Then we're going to talk about data quality engineering definitions, and I'll give you a very specific example of that. We'll look at the data quality engineering cycle and give you some contextual complications we have with data quality. We'll then look at data quality causes and dimensions, and then quality and the data lifecycle, and we'll finish up with a sort of romp through some data quality tools. And of course, then we'll finish at the end of the hour with some takeaways, and as Eileen said, the part we look forward to the most, which is getting everything up and running and talking to you guys about some of the questions that you have, which are always a lot of fun for us. Now, always we start out with this very complicated diagram that if anybody ever really wants me to go through it sometime, I'd be very happy to do it. This is the non-management version of what we mean by data management here, and I'll simplify it for us. Got our 5 specific integrated data management practice areas. The first one is data program coordination. That's the idea that we need to all be singing from the same sheet of paper, because when we look at organization after organization, we find heroics, people who are down in the bowels of IT who are trying to do data management, but they don't know that somebody else is trying to do the same thing. And so their efforts are simply not coordinated. And of course, if they're both working towards the same goal, the efforts would be more efficient in that area. Second function then, talking data management practice area, is sharing data across organizational boundaries. Again, your organization is very likely doing data transfer between one part of the organization to another, between a program to a program, or between your organization and a partner organization. We want to make those things as efficient and effective as possible, because if we don't, first of all, the security process becomes much more difficult, but second of all, it just isn't a good expenditure of organizational resources. Third area of practice in data management is data stewardship. This is assigning responsibilities for the data. If it is not personally responsible, if it is not Peter's responsibility to fix the customer data, then it's everybody's responsibility, which means nothing happens. So that's been the case in many areas. You'll see data stewardship now as a growing area, and we have a topic we do later on in the year for this. Development is a fourth area here. This is the ability to engineer data delivery systems. And words engineering and architecture come up time and time again in these areas, but they are woefully missing from our educational offerings in this area. And our area is data support operations. This is the idea of maintaining the availability of data within these organizations. And if you were lucky as an IT, and more importantly, not if you were lucky, but if your boss was lucky or your boss's boss was lucky, I've had a single course in data development, but most people do not have any education in those areas at all. So let's talk about now the management areas as a basis, a foundation for what we want to really do with data, which is leverage it. Now, I always use this picture of Maslow's hierarchy because data works very much in the same way. And those of you that remember Maslow from high school, this was the idea that if your food, clothing, and shelter needs are unmet, you're unlikely to sit down at night and create the great American novel. Again, that's just without a good foundation, it's unlikely for the rest of these things to happen. And our 5 data management practice areas are critical to doing this. What everybody learns about data is what gets written about in the press. We call advanced or self-actualizing data management practices, whether they are cloud, master data management, data mining, analytics, warehousing, big data, doesn't matter. If you do these things in the green area of the triangle without first providing a good foundation for your data management practices, it will take longer, cost more, deliver less, at greater risk to the organization. All these, of course, are wrapped up in our data management body of knowledge. Again, Eileen mentioned that I am the president of Data International, and this is our definition of what we mean by data management. These areas, Data is an international organization. These areas were developed by a group of dedicated volunteers that really made phenomenal efforts. In addition to just knowing what the body of knowledge is, now we can also talk about becoming certified as a data management professional. Again, I've got a couple links up there on the site. We would like you to join the growing list of about 1,200 professionals worldwide who are now certified as data management professionals. And more importantly than that number of certifications, we're also seeing a lot of job postings coming along where it states CMP preferred. And now that we know we're making a good impact in there. Those of you that are familiar with the DIMBOK understand that each of the chapters of the DIMBOK here have a IPO diagram here, and that's what we're looking at on the screen, inputs, activities or processes, and outputs on the other side to define the scope of what we mean by data quality engineering. And we can also throw our 5 data management practice areas into the middle there as well with the same kinds of results on this. So let's dive into the material now, data quality definitions here. First of all, I'm going to describe to you a model of what we mean by data. Data, of course, is a random fact and useless at all unless we pair it with a meaning. So if I give you the number 42, that was my age 12 years ago. Now you have a meaning that you can pair with that particular fact. That is not really information yet, though, until we understand that this is the nature of a request that an organization might make. And what we really want to do, again, these self-actualizing things we talked about a minute ago, are the getting to what we call intelligence, depending on which data it was. We also called it knowledge and wisdom. Interesting terms as being able to use in there. It really just depends on what decade it was that we did. But the idea is that data, information, and intelligence need to be built fully with an architecture and an engineering discipline, and that if we don't have a good foundation, everything else is built on a foundation of sand. Let's look at a definition of data quality. Martin Epler was the first that I heard to use this term, fit for use. It meets the requirements of the authors, the users, and the administrators. And a quick little Popeye story on this as well, because many people are familiar with the character Popeye from the cartoons. And Popeye is always eating spinach. And as I was doing a little bit of research for this, I found out that it turned out the reason people thought spinach was important was because of a data quality error. It turned out that the researcher who was studying the value of vitamins and iron in particular that were involved in spinach made data error and was off by a factor of 10, an order of magnitude. So for years and years, including the whole development of Popeye, people thought that spinach was really good for you. Spinach is good for you. It is no more good for you than kale or any other leafy green that is out there. It's a little data quality story out there. And unfortunately, we have to understand that this data quality is synonymous with information quality because of the slide that I showed you before and the very key interrelationship between data and quality. They are synonymous. If we have poor data quality, we will have inaccurate information and, more importantly, poor business performance. Let's talk about data quality management here, and you can see the definitions that we've got up, which are planning, implementation, and control activities. Great, that's good. Or entails the establishment of roles and responsibilities from a person perspective on this. The real key pieces here are that there's a change management component relative to data quality, as in which version of the truth am I looking at this point in time, and that it's a continuous process for defining acceptable levels of data quality to meet the business needs. And most people don't understand this. They think it's something that can be fixed, whereas it's not. It's a continuous process that is ongoing for organizations. So here, let's move to data quality engineering, and this is the recognition that data quality solutions can't be managed, but they must be engineered. If we try to manage data quality, it gets away from us very, very quickly. And engineering is this application of scientific, economic, social, and practical knowledge in order to design, build, and maintain solutions to our various data quality challenges. Engineering concepts, however, are generally not known and not understood by IT or the business. So let me give a very specific example on this as well. This is a customer that we worked with a couple of years back that had a catalog of information that had lots and lots, millions literally, of SKUs. SKU is a stock keeper's unit, or if you want to look at it in another context, it's a NSN, a national stock number that were maintained in a catalog here. And the key for this information and other data about the data was stored in clear text or comment fields. Again, not a very useful, certainly not a very accessible way of doing this. So the approach that people suggested in order to clean these was a manual approach. And while that was a fine approach, it did not apply engineering techniques in here. And the question was, how much could we do with an engineering approach, and how much should be left to a manual approach? It also left the data structuring problem relatively unsolved, so the solution was to develop a proprietary, improvable text extraction process. We were to convert the non-tabular data into tabular data, and by the way, those are the preferred terms to unstructured and structured data. When you hear people talking about structured and unstructured, if the data was unstructured, you couldn't structure it. That's the definition of unstructured data, so I don't like that. But here's the business value. We were able to save this organization $5 million, and I'll show you why. More importantly, though, it was the first time I've ever worked on a project where I saved a person century. And the person century is kind of an interesting concept. You hear person days and person weeks and person months and person years. We got some person centuries out of this one. Let me put up some numbers here, and I'll show you the engineering approach. Now, the key for this process was to determine when we reached diminishing returns with our algorithms that we were putting in place on this. And the first week we did this, we didn't do very well. We didn't really match anything. That's what I'm showing here. But by the fourth week, we had actually matched 50% of the problem, 55% in fact. And we were also able to improve our number that we could ignore. In other words, of all of the millions of items that we were looking at, by the fourth week, we had determined that we could ignore 12% of them. That was pretty good news, too. It meant we didn't have to spend any effort to clean those items. And the number of unmatched items kind of varied a little bit here as we worked with our algorithm. So we've done value value. That's great. When do we stop? Now, the interesting part about this is that we're holding certain costs fixed. And that was the weekly amount of software engineering that we put into this, and data engineering I should add as well. So each week is a fixed cost on this particular project. You'll notice that the unmatched items by week 14 had dropped down to 9%. And in fact, by week 18, we'd actually dropped down to 7.5% here. So looking at that, we were seeing that they were getting lower. The question was, how much lower would they go? Ignorable items, we pretty much got to the idea that 22.62% of them we could ignore entirely, which was 1/5 of the problem we could completely discard. And our improvable items, the number that we were matching, went from 68 to 69%. So you could see we were clearly approaching a point of diminishing returns. And in fact, the original problem space had gone down where we were able to match 70% of them, ignore 22.5%, which only left us with 7.46% of the problem originally. Now look at this from a quantitative perspective. We took the chain NSNs and added 5 minutes to cleanse and review them. We multiplied that times the number of work weeks in a year and the weeks in a day, all the rest of the things that we put in there. And the average salary for a SME on this, and that's where we got our $5 million in saving. The person years, you can see a little above that, is the 5th or 6th line from the bottom, is 92.6 person years on this. Of course, one of the important pieces on this chart that we do, and a little bit of civil engineering on this, was the number 5 minutes to cleanse and review. I don't know about you all, but you simply can't usually fix a problem in 5 minutes. It doesn't work that way. And so consequently, if we double that, we ended up with 2-person centuries, and again, $10 million, 15 minutes, right, gives 3-person centuries and $15 million on this. So some very tangible value here by applying a combination of engineering and automation to a very, very intractable problem that we had before. One of the things that we see here, there's that error we were looking for, Eileen. Look at that, right there on that slide. All right, we'll make a note of that, slide 20. We see these things out there when you look around in the web, and it's just fine. You've got 6 misconceptions about data. You can fix it. Data quality is an IT problem. Data is a source entry or data entry problem. A data warehouse will always give you a single version of the truth. A new system will give you a single version of the truth. And standardization will fix all of these things. And they're wonderful things to think about, but they are much more aspirational rather than reality-based. In reality, when you look at this, it's much more like the story of the blind people and the elephant. So you've probably all heard this story. There's a lot of people, and the first gets up to the elephant, and he feels the broad side, and he says, oh, the elephant's like a wall. The second one feels the tusk, and he says, no, it's like a spear. And the third one takes the trunk in his hands and says, no, it's like a snake. And the fourth reaches out and feels the elephant's feet, and he says, oh my gosh, it's like a tree, right? So everybody has their own perspective on this. And yes, this is true about data quality too. Most organizations approach data quality in the same way the blind people approach the elephant. They only tend to see the data that's in front of them relative to one particular process. And that is a problem. There's little cooperation across boundaries. It leads to confusion, disputes, and narrow views. I was on a project one time where we literally had to wait for an individual to retire. That's a story I'll have to tell offline, but it literally was a multi-million-dollar decision for this organization. So our solution is that data quality engineering can help us to achieve a more complete picture and facilitate cross-boundary communications on these. Now, if you know that we do some polling questions on this, and after this slide, I'm going to ask you all a question to participate because we're interested in how it's going. We've been taking these measurements over the past couple of years. But let me just give you, before we get there, a structured definition for data quality engineering. That is that it allows the form of the problem to guide the form of the solution. It provides a means of decomposing the problem, gives us a variety of tools for understanding the system that we're dealing with. It offers a set of strategies for evolving a solution. It provides criteria for evaluating the various solutions and facilitates development of a framework for developing organizational knowledge. So my question for you all is, does your organization address or plan to address formally data quality and information issues? We're giving you 4 choices here because, as I said, we keep these things year to year, and we're trying to see which way the trend is. So we'd love you to tell us, did you do it last year? Are you doing it this year? Are you going to do it next year, or do you hope to do it next year? And we've been asking those questions, as I said, for a number of years. So we'll give you exactly, Shannon says, 0.7 minutes to answer this question, because that's the optimal amount of time to get the responses from you guys. So we're getting responses. I should remember to put the Jeopardy theme music up on this one.
Yep. So
We get this.
yeah, trying to share.
I need your help.
Sorry
there we
about
go.
that.
Okay.
Nope.
Everybody's hitting the button and nothing's happening, right? So getting some good responses here. About 14% of you did last year, 32% are working on this year, 6% they hope to next year, and we didn't get any response at all from a third of you all. So thank you for your participation on that, and let's move on with the presentation then. So we're just about the data quality engineering cycle and a little bit of complications that occur on this as well. And I'll give you another story here. I was in Japan last year and went to visit these guys. It's a company called Mizuho Securities, very fine company, but they had an error that occurred on them that became infamous around here, and I'll tell you the story here. They had a trader who wanted to sell one share of a company called JCOM for 600,000 yen. That was about $5,000. It's a fairly simple transaction if you're on a good day. Unfortunately, this trader sold 600,000 shares for 1 yen. A little bit of dyslexia in there. Now, that resulted in a $350 million loss. And when I visited these guys, even though this was clearly years ago that occurred in 2005, they were still literally ashamed that this had occurred, that this had been allowed to occur in their organization. And the reason it occurred was because the in-house system for doing trades did not have any limit checking. Clearly, if you're selling stuff in shares and they're measured in fairly large amounts of money, 1 yen should not be allowed as a price. It's just a low price for anything that's in there. Similarly, the Tokyo Stock Exchange, where the trade went out, didn't have limit checking either. And finally, it didn't allow order cancellations. All of these combined to make this a very, very noted error in the securities industry, and everybody, because of the public, went around and improved their systems, their data quality engineering systems, as a result, so that they were able to hopefully avoid this type of problem in the future. Of course, we can't be totally proactive about it. And again, I see a lot of things out there in the web to read, where 4 ways of making your data sparkle. Again, we'll real briefly here. Prioritize the task, involve the data owner, keep future data clean, and align your staff with business, right? Well, great advice, but it's kind of one of those tastes great, less filling kind of things. There is a data quality engineering cycle here, and let's walk through it very briefly. It's based on the naming cycle, plan, do, study, act, or plan, do, act. Again, we're going to identify, define, identify again, and define business rules crucial around these areas. Let's take a look specifically here. Again, planning, we're trying to say what's going on, what's the cost and impact, and what are the various alternatives that we're going to have to look at as we go through this. And then the process for measuring and improving the quality of the data. This is where this configure management becomes so critical on this. Now, they must start out by doing inspections and monitoring and fixing things as you find them. The monitoring portion of it here says, well, we've got some business rules. In the Mizuho Securities example, we clearly would not have allowed anybody to sell a share of stock for 1 yen. That's like a penny stock. And if you're on the real exchange, the penny stocks don't count in there. And our fourth piece, again, acting. Now that we've looked at this, can we figure out what happens? And within the context of as we're doing this, what should we do next? In other words, what action did we take? How did that action work? And then what do we do next? Now, again, very straightforward in terms of putting this together, but let's add in another complication on this, which is that much of what's been written about in this area says things like you saw on that 6th slide earlier. Well, we won't have any data that we will fix unless we fixed all of the data. Well, my friend Redmond likes to think of data as comprising a lake. And while it's okay to clean the data in the lake, that's terrific. Do you have all of your data 100% perfect? And if you clean the lake, where's the actual source of the pollution? If it's upstream, whether it's upstream systems or something else that's happening externally to your organization, you probably need to fix that as well, or you'll spend all of your time cleaning the data in the lake over and over and over again. So to our old friend Pareto, which gives the 80-20 rule, it says that not all data is of equal importance. You have to add into that, again, this scientific, economic, social, and practical knowledge in here in order to figure this out. Now, we were working with another company at one point where we were able to actually stop production because we did discover that this particular data quality error that they were dealing with for the organization to in fact stop production of things. So when we had a data quality error, the system would literally lock up and they'd get a screen popped up in front of them that said, you need to fix this now before anything else happens, because many things downstream depend on the accuracy of this data being correct. Again, that's not necessarily something that's going to work for all organizations, so you need to evaluate these types of decisions rather than simply reading them off a website and saying, sounds great, let's do it, to understand how this is going to work in context for you. Now, another area that's occurred in here as well is that data quality is now being seen as a very significant amount of risk by certified risk professionals, people whose job it is to manage risk from an organizational perspective. Now look at things, and here's some notes from a project that we were on at one point in time, where they said the blank customer has 4 different databases, each of which may contain the same customer multiple times with active open balances. They rated the quality of the conversion data very high. So these risk management professionals are now starting to see this as a major area in this. And again, it will become more and more important as we go forward with this. So let's look at our next one, which is the data quality causes and dimensions in here. And again, this is an area that most people are not really familiar with. There are 2 distinct types of activities that support data quality, and data quality best practices depend on both practice-oriented activities as well as structure-oriented activities. And we'll talk about those for just a minute, because if we don't address both of these, we will not achieve data quality. If you're in an organization or planning to be in an organization that is looking at this, make certain that whoever you have helping you out with this, or that your organization has in fact taken on both of these activities, because if they don't, you will only fix part of your problem. Again, like fix only the data lake and not correcting the upstream problem, just to give you something like this. So our practice-oriented causes here, these are failures to capture and manipulate data. It may be something like edit masking, range checking, CRC checking of transmitted data. Again, if you're not familiar with these, we can certainly come back to them at the Q&A session. But they affect also data quality, data value quality and data representation quality. We'll get into those pieces in just a minute. But presenting the data out of sequence, it's giving you imprecise data or things like that, typically diagnosed in a bottom-up manner, where we find what's error about this, and we address it by looking at data handling governance. When people are met with the data, we need to give them some idea of what's going on in there. The structure-oriented activities, however, occur because the data and the metadata has been arranged imperfectly. And this means that even if you do a terrific job with your practice-oriented activities, if your structure is flawed, you will not be able to get data that is fit for use. These occur when, for example, the data is in the system, but we just can't get to it, where we have a correct data value provided as the wrong response to a query, or when data is simply unavailable or inaccessible in this area. And the reason we have this challenge is because developers, when they're building, focus within system boundaries instead of within organizational boundaries or across boundaries. These structure-oriented activities affect the data model quality and the data architecture quality. And at this point, you usually get a question where people say, well, I've got packages. Don't the packages take care of this for you? So the last 3 projects that we've been on at Data Blueprint, our customers have purchased packages. And we've asked them, and I'll tell you one story just very briefly on this. The customer said, well, we've got a new package coming in. It's going to run some of our laboratory software. And we said, okay, well, why don't you ask the vendor for a copy of the data model of the software that comes in? Now, here's the interesting part. The software was 3 weeks shipping, and the answer we back yet was the data model's not stable, so we can't ship it to you. I hope some of you are laughing at this point. It is not a good prognosis for the software, and we left them with a very careful set of instructions that said, here's your business practices, here's the architectural components that are going to be affected by this software. You need to check this stuff out before you put it in place because it's not going to allow you to do your business if it doesn't work. And guess what? It didn't work out so well. So, story. We then went and worked with the vendor of the software and fixed the data problem for them. So we had another customer that came out of it, and we were able to prevent that customer from going further with this. Oriented activities include things like when somebody puts a package on an RFP for you and says, we think we can solve a business problem with this particular software package. Go to your purchasing people, say, hey, I think a really good idea if these people gave us a data model as part of the evaluation package so we can see whether this data model fits within our existing business practices, whether it complements what we're trying to do. Again, what we're going to do here from data quality is look at a combination of practice-related and structure-related pieces. The practice-related pieces affect the data quality values and the representation, and the structure-related are the quality of the models and the quality of the architecture. I'll give you a very specific example of this. To do a full disclaimer on this, SunTrust has been Data Blueprint's bank since its inception. It's been 14 years now. We have a terrific relationship with these guys, and we really like working with them. But we did an interesting letter from them one day that's, but we've given one of your employees a gift card. So we got on the telephone with this particular person and said, oh, okay, a gift card. What can we use the gift card for? And they said, oh, well, you can use it to go buy anything at all. And we said, oh, really, like what? And they said, well, you know, could we buy a car with it? And at that point, the person looked down and said, oh, my goodness, did we really send you a gift card with a zero balance? And we said, why? I thought it was just a representation problem, and there was $1 billion on the card, and it just was an overflow problem. You can see what happened here. The bank didn't know they had made an error. Again, a limit checking tool would have been very, very useful under these circumstances, but tools alone would not have prevented the problem. And more importantly, any other customer besides Data Blueprint might have lost confidence in the bank's ability to manage those particular funds. So again, we had a little bit of fun with them on that one, but it's not an unusual or a completely unknown occurrence as we're looking at these things. Different challenges, different ways of approaching it requires a more holistic solution to do this. Now let's move into some quality dimensions here. I've already mentioned them previously: value, data representation, data model, and data architecture. And again, grouped into practice and structure-oriented pieces of it. You can see here from this chart that most data quality engineering has been focused on the operational problem correction. They're directing attention towards practice-oriented imperfections as opposed to looking at the structures of this. Now you can see on this particular chart, on the left-hand side, we are closer to the user, which is what the user sees, the representation quality, but we also have to pay attention to things that are closer to the architect. Again, the architecture quality, the model quality. One other piece of this diagram too is that one data architecture, that is organizational assets, spawns multiple data models, and those data models are understood by the specific individual developers. Whether you're building software yourself or buying it off the shelf, it still is implemented that way. Then each model represents one or more data value, one or more data value quality. These are the things that are maintained by the system, and then each value can have multiple representations. when they are presented to the user. So this is a much more complicated picture. It's not a ridiculously hard picture, but anybody that's trying to address just one aspect of this is missing out very, very significantly on this. And I'm adding that same picture here, show you the actual dimensions and the attributes of quality at each state. So this is the full set of data quality attributes here. I'm not going to walk through each of them, and you shouldn't either. What you should be doing is saying, in order to determine what is fit for use of our organization, we were going to say this and this, and we can make some judgments and use some utility in there in order to come up with this. Because if we try to do everything and get for perfect data 100% of the time, it doesn't work. And again, the other challenge with this is that most vendors, most organizations, most approach to data quality are focused on the left-hand side there. And I hope that you see that if you're working at that left-hand side on just the data representation quality without fixing the value, the context of the model, and the architecture, it's kind of like sitting at the bottom of Niagara Falls there in that little boat that's on the right-hand side of that diagram, trying to fix a water quality problem. It's an absurd waste of time and money, and we have customer after customer that we've worked with that have to do this. Of course, you could wait until the falls freeze over, but that's probably a good idea either. Global warming and everything else that goes on may be a while before we see Niagara Falls freeze over again. Now I'll take you to another interesting story here. This is a story from New York City, and they approximately 2.5 million trees in New York City. Now remember, there's only about 12 million people, so that's a fairly good person-to-tree ratio. And trees are kind of a problem in New York City. In the 11 months from 2009 to 10, they had 3 people killed or seriously injured in Central Park alone who had trouble with this. So there's an interesting belief that the people in New York City have, and arborists everywhere, that is that pruning and maintaining trees can keep them healthier and make them more likely to withstand a storm, decreasing the likelihood of property damages, injuries, and deaths. There is, until recently, virtually no research or data to back it up. It's wonderful to have a theory, but it helps a whole lot better if you have some data. So they took a look at this and said, wow, another question. Does pruning the trees in a single year reduce the number of hazardous tree conditions in the following year? It turned out, interestingly enough, this brought in all aspects of our problem. They had the wrong architecture to solve this. The data was at the wrong level of granularity. For example, the pruning data that they had in New York City was recorded block by block, but the cut data was only recorded at the actual address label. So in other words, I might come say I'm at 501 Park Avenue and I have a tree down in front. They need to come get me. And oh, by the way, trees aren't grown with unique identifiers. So that's a problem as well. So after downloading, cleaning, merging, analyzing, and intensive modeling, they found out that pruning trees for certain types of hazards caused a 22% reduction in the number of times the department had to send a crew for emergency cleanup. We have some evidence that pruning of the trees actually does result in significant savings of life and property, as well as cost to the people of New York City for this. Now, the best analysis generates further questions. And since New York can't prune each block every year, that's just an impossibility, they're now working on building what's called a block risk profile, looking at the number of trees, the types of trees, and whether the block is in a flood zone or a storm zone in order to come along and address this. Now, again, here you see examples of data architecture quality, data quality that get down to the value quality. I did find a representation quality in this particular example. Sometimes it's hard to get them all in one, but I hope you found that one kind of useful in there looking at it. So going on, let's look at data quality and the data quality life cycle. In this, I'm going to give you another bank example here. Again, another good bank that we've been friends with for a while. Chase and Bank One back a couple of years ago. Let's see, this is I forget what this was. Oh, look at this, an undated letter. Wow. Okay, it's interesting for starters. So I got this letter, and if you look carefully at your screen there, you can see the letter is literally crumpled. And the reason it's crumpled is because when I got this letter, I looked at it and said, I'm not a Chase customer. trash can. The outside of the letter had only a Chase envelope on it. It did not have the Bank One logo, and I was a Bank One customer on this. And if you read the letter carefully, it's got some little text in there. It says, please be on the lookout for any upcoming communications from Chase or Bank One regarding your Bank One credit card and any other Bank One product you may have. In other words, I initially discarded the letter, even though I was a Bank One customer. I became a little bit upset after reading it, and it did tell me that Chase had some data quality challenges. So we're popping up onto another polling question here for you, but let me just talk about this for a minute. So if the goal of this was to use up all of the old Chase letterhead, okay, but literally I did take this letter and throw it in the trash can. I saw in the news later on that week that Chase Bank One, and I said, oh my goodness, I saw something from Chase. And I went back to the trash can, smoothed the letter out, and looked at it and said, oh, wow. And then I read it, of course, and again, it says just twice in there, please continue to open your mail from either Chase or Bank One. And then at the very bottom, you can see the PS as well. PS, be on the lookout for any upcoming communication from either Chase or Bank One regarding your Bank One credit card or any other Bank One product that you may have. In other words, they don't know their customers very well, and they were making me do work that they should be doing, which is telling me, hey, we bought your credit card, so we should at least use your logo on it so that I'm fully aware. Again, I see this as a data quality challenge. Some people like to disagree with me on this, and I'll be happy to take those on during the Q&A session on this. But let's go to the next polling question here. Does your organization utilize a structured or formal approach to information quality? And the answers we're looking for here are yes, they say they are, but they aren't, or no. And again, we get some very interesting responses on this. So again, we'll give you the 0.7 minutes optimal response time here, because we use to manage these things, don't we, Eileen? That's right. Actually, that's a number, but still. Smart when we learn stuff. Channel data too, that's right. Now, after you see data diversity, how could you not like it? Oh, I started pulling up my iPhone before. We won't have time on this one, but let's just see if I can find the Jeopardy theme music. Looks like it'll be good this time.
Let me share the poll results with everyone. Oh, there we go. Here you go.
Okay, again, yes, 17%, 22% say they are, but they aren't. And thank you for that. And obviously there's no attribution here. And 30% are not. And we're still getting 30% that are not answering. So I wonder if we've got a little technical glitch that may be going on there. We'll take a look at that as well. We're moving up to the home cycle here. And I mentioned Tom Redmond before. Tom's been a great friend for many years, and this just is the evolution in our collective thinking that we've had. His first book that he published on data quality in 1993 gave a very natural feeling approach to what a life cycle looked like for data. It was data acquisition activities, then we had storage, and then we had data usage activities. And that's terrific for 1993. But here we are in 2013. And let's talk about how the data life cycle really works in here. We really need to start out with metadata creation, because we need a place to put the data, and that's an acknowledgement that data architecture and models have to be used to create a structure for the metadata. This structure is then populated with the data models in the storage location in an activity, a phase called data creation. That allows us to store the data values someplace where we need them to be. Data at that point can be utilized, and we might have a data utilization process. We might actually take some of those data values and manipulate them, and perhaps even restore those data values into there. Those data values can also be assessed, and we'll talk about that in just a minute. We can also then, after we assess them, manipulate them further. We can refine the data values, which particularly focus on data value defects that occur in there. And finally, if we decide that they are structural defects, we need to go back up and refine the metadata that's in there. So this is a more complicated data life cycle. And I'm going to do it one more time for you here to let you see now the architecture refinements that have to occur, the model quality. It's a little bit more complicated as we go through this. Whoops, sorry, I finished that one up. The model quality, the quality, the data value, the data representation. Again, each of these phases that you're in requires a different approach to doing your data quality resolution on this. And these now have challenges for us that we need to pay attention to. So again, if you see somebody coming into your organization and simply trying to address one aspect of this, it cannot happen. Now, people look at this chart and they really don't like it. It's kind of messy, so they said make it a circle. And so we did look at it and tried to make it a circle here. You can notice that there's 2 points to this particular circle. If you're in the upper left-hand corner for new system development, you start out with your metadata creation. If you're in the bottom right-hand corner, that's the starting point for existing systems. But either way, it leads you around this phased approach to looking at data quality and determining where you are and which tools you should use as you're moving towards this. Now, I asked you just before we got started for our third polling question, the way I get my clip art for these poll questions is I take the text of the question. So the text of the question here is, do you use meta models, modeling tools, or profiling to support your information quality efforts? And I plug it into images.google.com. And that's the image that came up. I'm not sure what it is or who that is, but that's what came up. But we're interested here to see whether you're using these metadata tools, modeling tools, or profiling in order to support this. Because again, we find most organizations are simply not aware of these tools. And if you don't know what you don't know, it becomes very, very difficult to do a complete and comprehensive job paying attention to these. We'll give you again that 0.7 minutes to respond on this thing. I don't think I pay Merv Griffith unless I play more than that. Really interesting. He said that he made more money on that song than any other thing that he did in his lifetime. Very, very interesting. What do we have for results, Eileen?
Hold on one second. There we go.
Okay, so we're seeing increases here. This is good. Again, some of you aren't answering, and maybe we're not being clear about the questions, but more are saying yes. And that's terrific. We're glad to see that's happening. Over time, that number has been improving gradually. Again, we'll keep doing this poll so that we can find out what's happening overall over time on this. So again, for your participation, let's look at some data quality tools here. And again, what's happening here, there's sort of 2 different approaches, a bottom-up versus a top-down. They don't have to be done in an absolute dichotomy on this, but it is important to at least consider whether you're going to start bottom-up, which is usually without management approval, or whether something bad has happened organizationally, in which case you may be going top-down on these things. Bottom-up is the actual inspection of the data sets and trying to find specific issues that are based on automation, so they're happening fast. And top-down is the business users are telling us they're unable to do the kinds of analyses that they need to do with these things, and they need to understand how their business processes consume and produce data elements. And this also helps us to identify which data elements are more crucial to the business success. Once you do that, you want to start looking at specific measures. Most everybody calls these metrics. Metrics is not a very useful word, so there really are measures. And again, that's identify one of the areas for critical business impact, identify the specific dependent data elements that create and update processes associated with business impact. Those data requirements specify the quality dimensions or business rules that are relative to that, and then describe a process for measuring conformance to get to an acceptable threshold in this area. These are good areas to do, and this leads you then to the ability to set and evaluate various data quality service levels. So again, as you're looking at these SLAs, I'll tell you a quick little story on this. I'm working with a company that basically business model was to sell magazine subscriptions. And when they got the magazine subscription information, the place they were sending the physical magazine to the customer, they'd use that information to sell other stuff into them. I want to say kind of a Time Life thing. It was not Time Life, but you know, if you buy something from Time Life, they've all of a sudden got lots of other things that you might be interested in to sell you in this. Well, if data coming into them, they outsourced it, it turned out to be only about 30% accurate. It was a big problem back then. We'll forget about the fact that the paper-based magazine subscription seems to be something that is not long for the world either. Now, return service level agreements, it talks about which data elements are covered by the agreements, what impact is associated with the specific clause, which data quality dimensions are associated with each element, and then what are the expectations around these so that we can put in place measures that allow us to succeed and understand so that we can measure, monitor, and manage these things. Again, we can look at it in stream while we're collecting it as we go through with it, or in a batch mode where we go in periodically and try to do it. We probably need to determine which of the three levels of granularity we're going to apply the measurements again. Again, it might be at the element value, it might be at the instance or the record level, or it might be to the data set as a whole. Each of these are very important decisions for you as you're working your way through this. We'll spend the last 10 minutes here now talking about some data quality tools. There are categories of activities that have to do with analyzing the data, cleaning it, enhancing it, and monitoring the data quality that you have in your organization. And the principal tool sets, there's 6 different ones: data profiling, parsing and standardization, transformation, identity resolution and mapping, and enhancement and reporting. Let's start in order. First one is a set that I was involved in early on at the Department of Defense as we started to do this. I spent a large part of my days working in the basement of the Pentagon, working on data architecture and data quality type problems. And I realized that these were not going to work in a simply manual mode. There was just relying too much on human intervention for these things. So we developed a series of grants that we sent out to the universities, and it turned out that Columbia University, a woman named Dina Bitton, wonderful PhD, was able to develop the basics for this process called data profiling. Now, most people have at least heard of this at this point in time. The algorithms allow us to go through and do statistical analysis and assessment of values within a specific data set, but then also to retain that metadata knowledge as we incorporate additional data quality tools and also additional data sets in there as well. So we can look and see what happens. Now, the other part that we were addressing in this from the DoD perspective was that we had these subject matter experts that we needed to have access to. Again, if we were working in a domain like healthcare, for example, the data quality people were not familiar with healthcare. So we had to use large amounts of time of these SMEs, these subject matter experts. And these algorithms that Dina created allowed us to make inferences about the data. It's literally an inference engine. And when we had inferences in place, we could then go forward and say, what's actually happening? And we would go to the users and say, not tell us about your business, which gives you a blank screen and something that is typically terrifying for most people, but instead we could say, we believe this is happening. Can you confirm or deny our hypothesis? And they were much happier to edit our hypotheses and our findings than they were to, in fact, create them for us. This allowed us to understand both the semantic and the logical levels. In fact, with data profiling tools, you can take any data set anywhere and develop a logical third normal form of that data set. So if you have a software package that you don't understand what's inside, you can look at the data going into this and look at these rules. By the way, you do not need to buy a tool, although the tools are now rentable. You can rent them on the web, or you can rent them in software as a service delivery, or vendors will do it that way. But you can also apply your own, you can do manually yourself. When I teach this in classes, usually a student will come through and say, I could run that in SQL. And the answer is yes, you could. SQL, however, does not have the memory. You have to add some additional components into it so that you can then go across data sets in order to do this. So again, with your profiling, you can look at this and say, hey, here's some things that are happening. You can give an alert to the help desk, or you can take your business analysis and focus it more specifically on a various aspect, a specific aspect of the problem. Aside from a company we work with a lot called Global IDs, and I'll thank Arca for this particular slide because it just shows a process that his software can go through. He's got one of many tools that are out there, but it's a fairly comprehensive one here. And you'll notice they discover all the tables. For each table, they discover the metadata. For each schema, they discover the relationships. And for each schema point, they go in and get a metadata report, moving on which column. They go through and profile each column, and then for each schema, they double check the numbers for all columns. You can see this is a lot of work. And it turns out ARCA has recently reconfigured the Global ID engine to take care of Hadoop, which, as you know, is a big data technique, so that he can do a lot of this in parallel. I think he's got a fairly significant advantage out there. Don't want to give him too much of a commercial, but it is stuff that we use a lot and our customers are finding a lot of value from. Data quality number two is parsing and standardization. And again, this is the idea that we're going to look for specific patterns. You may have seen this in address normalization. The post office does a terrific job of trying to identify these things so we don't end up with things at the street. What do we want as the standard definition in order to do this? You've probably also seen it where you have a order online and the order online comes back and says, just put in your zip code and I'll figure the rest of it out for you. Or it may ask you a question of which one of these two counties are you in if the zip code happens to go across multiple counties. The information, if in column 1, then make the value male, female. We know that's a wrong thing to do. We in fact want to say test for each value. So if F, then female. If I, then indeterminate. And again, there's actually 9 of those that you can look at in here. But these data transformation tools allow us to go in and map the original values onto what sort of target representation we'd like to have. So we can now do this with a rules-based engine. Identification and mapping, another set of tools here, which is to look at whether it is deterministic, relying on the patterns for assigning weights and becoming predictable, or whether it's probabilistic, as in there are 52% women in the United States and 48% men. So therefore it's a more probabilistic that T is a female rather than a male in that particular example. Enhancement of the data, again, adding additional metadata onto things where we can add timestamps, auditing components. You've all heard probably of the fact that your smartphones now take pictures and geocode stamp your picture. So if you take a picture of somebody and post it on Facebook, somebody else can take that picture and figure out what part of the country you live in, what part of the country you are taking that picture in, and whether you are in fact at home or not. That's a little bit scary, but we should be a little bit careful about what's going on in that area as well. Sixth tool, again, class of reporting tools here that just allow us to go in and see what's going on from an overall perspective, whether or not these service level agreements are working and how it's working in our organization here. So that's the set of tools real quick. Let's just take a couple of takeaways in the last couple seconds that we have here. Again, what we're trying to do with data quality engineering is to develop and promote awareness, to define, get people in the habit of developing requirements, to learn how to process and analyze the data, to look out measures and metrics, business rules, quality requirements, service levels, learn how to monitor our data quality, how to manage the data quality challenges, learn how to correct, clean, and document the rules that we're finding out, implement the various performances that we find out, because this feeds us back into requirements for new systems, inspection policies for existing ones, and changes that go into this, which means we really have to understand a way of recording the expectation in the business rules, a way to measure the quality within that dimension, and understand what are acceptable thresholds so that we can get to fitness of use. So in about an hour here, we're walking through this data quality engineering portion of our area. I've included some additional information here for you just so that you know what's coming along, and I'll show it to you so that you can see this. These are the dimensions of data quality here. So this is the quality dimensions here, the value quality, the representation quality that occurs, the model quality, and the attribute quality. That's just a little bit of reference information there for you. And with that, we are just about at the top of the hour, and I will turn it back over to Eileen so she can talk to us about what sort of questions you guys have.
Great, Peter. That was a great presentation. And everyone, now it's time for our Q&A. So if you can't currently see the Q&A panel, just raise your mouse to the top of the screen, and you should be able to get it back that way. We do have some question and comments come in throughout the presentation, so I'll just start with the rest of that one. Our first point question actually sparked a few comments. Let me read it back to you, and if you want to pull it up, Peter, it was, does your organization address or plan to address data information quality issues? And some people saying, well, one answer, so we should have included, was not the above. I guess we were just trying to be optimistic that something is being done, that it is being recognized. And then also, somebody pointed out, what about ongoing as an option? Shouldn't this be an ongoing issue or an ongoing something that we address on an ongoing basis?
Absolutely valid points. And just to respond, this is an interesting component. When we did the survey the first time, we did it wrong. We did it in this fashion. Gosh, the first one we did was about 15 years ago. And so we've kept that error in there all the way so we can compare like results. But you can see the importance of doing this. So again, thank you for pointing that out. That certainly is a data quality error, and unfortunately, we're stuck with that one for a while.
Okay, and then we had another question on the section where you're talking about how there's two distinct activities that support quality data, and there's a slide on the practice-oriented activities. One of the bullets was CRC checking off transmitted data, and what exactly
Sure, great.
that means.
Let me get to that slide here. So that is a practice-oriented activity, and it is possible to build an algorithm that if I send a data set, whether it is a single file or a group of files, that we can add what are called redundancy checking into them. And we add across the row, and the answer should always be odd or even, for example, or something along those. It's a lower level of security than actually a signed set or signed email, but it is something that you can build in so that if somebody gets this row of data or collection of data, and they can see whether or not it was in fact transmitted properly, whether a transmission error has occurred in that translation of the data. So CRC checking is a very standard engineering technique for using. Many organizations, particularly as you're transferring stuff to or from the cloud, use this to make sure that what you get is in fact what you were supposed to get. It didn't tell you about the quality of the stuff in there, but it does tell you that nothing got changed during the transmission of that data. So I hope that's helpful. If you haven't seen that before, it's certainly something, particularly if you're doing a lot of data transmission around your organization, or you happen to be working under adverse conditions where transmission errors often occur.
And the next question, could you clarify the term of metadata? When does data become metadata?
So that's a great question, and it happens to lead into our next presentation we're going to do next month, which is on metadata. So you can learn a whole bunch more on it next month. But data and metadata are terms that are rightly often confused because they're improperly used. And I'll get into this a little bit more with the next webinar in here, but I'll give you the Gartner definition, which is a very good one. Gartner defines metadata as anything that adds value to data. As it's adding value to data, metadata therefore requires management attention. I don't have that slide on me right now, and I apologize if I said that quickly. We will put that into that is in the next webinar. But let's just go back to my slide on 42. I talk about 42. Some of you may also think of the movie 42 that is out right now. Some of you who are older may think 42, that was something from Douglas Adams' Hitchhiker's Guide to the Galaxy. It's actually the meaning of life. So each of those interpretations, my age 12 years ago, the meaning of life, or the football movie about, I think it's Jackie Robinson, 42 is the movie about Jackie Robinson. That meta tells you what we're referring to with that 42. It adds value. In other words, if I said, let's go see 42, and you don't happen to like tongue-in-cheek science fiction, you probably don't want to go see the Hitchhiker's Guide to the Galaxy movie, but you may in fact want to go see the movie about Jackie Robinson. Somebody correct if I don't have that term on Jackie Robinson. I can't get to my screen right at the moment here. But anyway, so metadata is this additional piece that goes on, adds something to it. Again, if I'm trying to find out whether Peter is old enough to buy alcohol, in Richmond, Virginia, the metadata that you used to do this was whether we had facial hair or not. And if you had facial hair, a mustache, a beard, a goatee, anything along those lines, you were probably over 18, which was the age we could buy liquor at when I was that age, and you were allowed to have it. So people would actually put fake niches on and things like that in those days, because that was the metadata that you needed to have in order to be able to buy beer. I hope that's an answer for you on that metadata. It's something that adds value to data. Oh, by the way, let me give you one other piece on this too, which is sort of proof of the upcoming webinar on this. But the question is not whether you're looking at something and deciding whether or not it's metadata. That's the wrong question to ask, because anybody's data can be anybody else's metadata. Metadata really involves a transference of a level of abstraction around something, and that gets a little bit tricky on that, and it's not really helpful. The question becomes, should we include this item in the scope of our metadata practices? And that's a very useful question to ask, because there's a value that you can obtain from that. In fact, look at this. Let's talk metadata for another quick second here, though, because there's been a lot of talk of metadata this week, hasn't there? With all the, NSA and domestic observance of this. And the person came out the other day and said, look, we're not looking at what your telephone conversations were. We're simply looking at the fact that you had a conversation. And by the way, it's all legal under the law today. It's very, very clear that this is legal. But again, I'll take an example here that somebody put at the Electronic Feature Foundation just recently. If I'm making a phone call to a suicide prevention hotline, and the origin of the call was the middle of the Golden Gate Bridge, we learned some stuff about what the data of that call was about. We can infer some things about it. Similarly, too, if I happen to call a 900 number and have an 18-minute conversation, and that 900 number sells delightful services, that may be something that we can infer from that as well. So again, metadata is a key piece to pay attention to. And by the way, if you have poor quality metadata, you're certainly not going to be able to have quality data. So it does give it to another piece on it. I hope that little 5-minute soliloquy on meta was helpful to you. If not, please ask another question.
Next question. Upcoming informatics, data mining, data engineering major, what is the best piece of advice you could give me?
It's terrific that you're interested in this. We do find that when we study this as a career field, it usually takes people about 10 years of IT work before they decide that this stuff is important. Congratulations to you for discovering this early on. What I would do is to see how much practical experience that you can get. And I would also, one other piece of advice too, which is to, while the book learning is good, there's nothing that substitutes for the real actual learning that occurs. Again, I reference you back to my blind man and the elephant scenario here, where we look at this, really trying to figure out what is metadata. What is data quality? Because it ends up being different things to different people as we look at it. There we go. There's my blind and the elephant slide. And is that we can do lots of things from college and university, and we've been working on that for a long time, but that will not make you into a person who's able to do this. The soft skills that you need to have come from the real world experience. And so if you're able to volunteer, and by the way, I don't imagine a corporation in the world is going to object if you walk in there as a person who says, I want to do a job for you guys, but I'd also like to help you guys improve the quality of your data. When people do that, most of the time people say, pull this man up a desk, give him a fat computer, and let him get started. I said, man, boy, that's terrible. I apologize. It could have been a female as well, and hopefully you'll stick me that one. There's a quality problem right there. So get some experience as you can. Almost all universities will let you have what we call an independent study or an internship of some sort in order to do this. And if you have trouble with that, reach out and give us a shout. We can maybe arrange for something for you as well. Good luck to you in your career. Oh, let me give you one other piece of advice too. I know you only asked for one, but look at things going badly in IT. We call them a science project, and I'm really kind of afraid that people are calling these data scientists things without understanding the context for it. So I'm not sure I would go and label myself a data scientist in that context. I think we've got to do a little bit more work on our career fields and labels before we get into that. But certainly if you walk into organizations and say, I'd like to work on data quality problems, most of them don't have enough time and effort to do that, and they will be very grateful to you for paying time and attention to this. I can also recommend a reading list to you. You can see it at the end of the presentation here, but please do reach out. Love to find out who that is.
Okay, and Peter, given the complexity of the processes of data quality, what's the fastest way to become conversant with them? Can best practices you already followed, or is the devil in the details? For example, data cleaning is 80% of the work regardless.
That's a great question. I would suggest here is that relate a story. When I was with the Department of Defense, we were starting in 1992 to work with the Y2K problem. Some of you may not remember or be familiar with the Y2K problem, but it was the computer problem that was going to take all of the dates that were only represented by a two-digit number, as in today would be 13, and if we wanted to find out what happened 2 years ago, we would subtract 11 from 13 and get 2. But of course, if you subtracted my birth year, 59, from 13, you'd end up with a very different number, and in fact an incorrect number. Some have called it the biggest data quality problem that we've actually successfully addressed to date on that. And it had similar complexities in that. So one of the things we did, and I was working with a fellow named Russ Richards, who was just a terrific guy to work with, was a mentor for me for a couple of years in there. What Russ did is he put it all in context. So we developed a essential data flow of how data was coming along throughout the Department of Defense. And this model allowed us to go in and see where we could be most effective in doing this. So again, I'll relate you to the metaphor that I used earlier on from Tom Redman in there. Let's see, that's the slide here. And know that the data quality is just in the lake, the data quality challenge is just in the lake, you're at least informed enough to be able to say, hey, let's work on just the lake. But if you don't know, and it might in fact be something larger than that, then we maybe need to go upstream and don't look at the lake because the data doesn't stick around in the lake for very, very long. So getting this contextual information will tell you again about what type of problem that you're facing here, and then what type of tools you can use. And again, remember, we've covered a lot in here. Are we looking what dimension of data quality we're looking at, what phase of the life cycle, what set of data quality attributes are we looking to, what type of data tools are we looking at, and finally, where in the process should we apply engineering and architectural concepts, and where should we apply human beings to that? All of those are very complicated, but our customers are not confused when we walk into them and say, they come to us and say, we've got a data quality problem, and we present these kinds of things. It takes them, a little time, about as long as you guys have spent on this, before we get a grounding in this and then say, okay, now here's an area we think would be useful. Here's a tool that looks useful. Let's get started and see if it actually works. Again, I hope that answers your question.
Okay, next question. If the process has well-built preventive controls to ensure a clean river, is there still a business case to build and monitor data quality on an ongoing basis?
Well, that's up to you, isn't it? So in other words, if you have in place things that keep water from going into the lake for being polluted, and it's clean, it sounds to me like you've done an excellent job and should write a book about it, because we certainly can use some guidance in those areas and some success stories in those areas. On the other hand, if you think you've gotten them all and you haven't tested for it, I would advise a little bit of testing before I'd start yelling about success. And their data quality problems can be quite insidious and get into things that you just don't expect them to be. Again, like the blind man and the elephant piece there. So congratulations to you if you've gotten there. If not, double check it yourself every which way you can, and then tell them that the data seems to be currently in place, and also demonstrate the value of that, because it certainly didn't cost a lot of time and money to put in those preventative things. If you've been successful in this area, there's clearly a demonstrated business value there, and I would put some dollars on that so that people understand that by investing X, you are clearly saving your organization X plus something in order to come up with it. Again, you're doing unlocking business value. That's the core of our data blueprint philosophy here.
Next question, I think, is around some tools. Can you name some metadata tools?
Metadata tools? I sure could. Again, we could look at Platinum Repository or Rocher metadata tool or the True, TRUX metadata repository, but I'm not sure naming them is going to be helpful to you. Again, what you're trying to do is to figure out what it is you're trying to accomplish, and each of those tools have their own strengths and weaknesses. We'll talk more about them next time through, but I'm sure you have a more detailed question than that, so name some.
Well, let's see if maybe they comment and provide a little more detail. In the meantime, we can move on to the next. You've expressed that it's not possible to address everything at once. With limited resources, where should one start? What is the most important aspect to focus on?
Again, let's go back to context. So great question, and nobody has the resources that they need to get all the data perfect in their entire organization, unless you're dealing with a relatively confined set. The real question is what is the biggest area of risk in your organization? And if you don't know that, you can probably have a conversation with your chief level officers in the organization. And I'll put in a little plug for my book here as well, because that is one of the reasons we don't see a lot of this knowledge existing at the C levels of organization. It's not that people are bad or that people aren't smart, but people don't know what they don't know. And so to put somebody in charge of data as an asset in your organization. Because I guarantee you, if you go to your chief financial officer, ask them what is the biggest financial risk facing the organization, they will be able to list their top 3 things that keep them up at night. And I guarantee you that if you go to your CIO and ask them about technology risk, they'll be able to tell you the top 3 things that keep them up at night. I don't think anybody in most organizations thinks of data as an asset that needs to be managed in the same manner as your cash or your HR or other types of organizational assets. So I would actually go to the organization and say, what risks are you facing organizationally? And then backtrack from there and say, what role data play in those risks? For example, I'll make up something here on the spot, but again, my university, Virginia Commonwealth University, has been building dormitories for a number of years. We all of a sudden have a packet that we offer the students that costs beyond the financial means of most of those students. Those dormitories are going to sit open. Somebody else said that some of the big box retailers might as well be turned into jails at some point there, because again, the risk of customers not being able to get access to the transportation needs that they have. So I don't know your organization, I don't know where you're asking from, but find out what are the things that are keeping the executives up at night? What are the things that cause them to worry? And then look at how data plays a role in those worries. And more importantly, grab a copy of my book. It's not for you, it's for your boss's boss. But get them to read this so that they will understand that data as our sole, non-depreciable, non-depletable, durable strategic asset is something that we should pay attention to and make good all the way around.
The next question, since big data is on top of everyone's mind, are the data quality concerns a barrier to develop big data projects?
Good question. So big data is about trade-offs. And I don't even like to use the term big data because I guess that means the rest of us are all doing little data. But big data techniques do offer us the ability to gain insight into things faster. I gave a talk 2 months ago called Demystifying Big Data, and one of the things we talked about were the types of trade-offs. And outside of the big data techniques, we look at different types of things. And if you take a quick Google search on acid versus base, you will see some of these trade-offs that have papers written about them. Acid stands for atomicity and consistency types of things, which means you're going to get a correct answer, as in, do I have enough cash in my account to withdraw $100 without overdrawing and incurring penalties and fees? That's a very precise transaction. Big data is about eventual consistency. And so it's not the technique that you would want to use to tell me whether I could in fact withdraw $100, but that I might be able to use big data techniques to say about $100 a week seems to be about the amount you can withdraw and still keep your bank account solvent. So there are different aspects of quality in big data techniques, and they are good and bad. Again, technology is neutral on this, but if you don't understand the various trade-offs that are being made, it's going to be very, very difficult to apply. You would not apply, for example, precise representation quality of the data, because big data is much more about patterns and fuzziness than it is necessarily about specificity. That answers your question. It's certainly a good one.
Next question is regarding data governance and how you can use it for data quality. Do you have a standard best practices in terms of data governance? Achieve quality.
Yeah, I was sort of looking for the other half of the question on that one. So there are some best practices around data governance, and gosh, what a great time to make a plug, because Eileen and I are getting on airplanes next week, and we're going from Richmond to San Diego, where we're going to be hosting the, we're going to be participating in the Data Quality and Information Governance Conference that we do out there once a year. And there will be a bunch of best practices presented there. So if it's not too late to hop on an airplane, I think that Davida told me over 300 people are going to be attending there. That should be a exciting event. I will be speaking on an aspect of governance that is relevant to your question, which my title, which I'm doing with a customer of ours, Michael Matura, great friends become over the years. It's called a three-legged stool, and one of the lessons that his organization has learned is that just buying the technology alone was insufficient to achieve the quality that their organizational business practices depended upon. The other two legs of the stool are people and processes. So buying technology alone is insufficient because it doesn't give you the architectural support that you need to have. You also need to include in it, again, the right types of people with the knowledge, skills, and abilities. And some of you have been on this call clearly. But in addition to that, processes around here as well. So I guess a governance practice, I can give you a couple of things that will be helpful. First of all, the governance group should be reporting to the business and not to IT. That's a little argument that I make in the book, but IT does not feel the pain of data quality errors. The business feels the quality of that pain. So to reduce the communication issues in there, we definitely want to have the data governance group reporting into the business. In fact, the chief officer should be reporting in at the same level that the chief information technology officer reports into as well. Another component of that, though, in addition, is that the language of data governance is all metadata. Metadata is what will control the various service levels that you're going to be asking for and things like that in your organization as well. Again, each of these are going to be important. Obviously, we won't be covering a whole lot of metadata today, but we certainly will get to those issues as we come up in the next session as well. So again, the language data governance is metadata. If you're not speaking metadata in there, please make sure that your data governance group is in fact speaking metadata, because if they're not, they're losing the opportunity to really get some good value out of what's happening there, and forcing additional translations in there which are problematic all the way around. Did that all the parts of that question, Eileen?
I think so. Yep. I think so. Let's do the next one. We still have plenty of them. Do you expect data quality as a service, that is the automation of this process, to ever become possible?
Well, it's certainly possible through service level agreements now, and it's also possible to use data quality tools that are cloud-based, which is software as a service. So I think the short answer to your question is yes, but just like we've learned with outsourcing, the hard part about this is not the technology part about it. The hard part about this is getting the process correct. So again, I've had organizations that have outsourced different aspects of their business, and they send over to some very fine folks that are in a different part of the world who work on it and correctly implement the things they were asked to do, but it still doesn't meet the business needs, because unfortunately one group is participating at a low level of maturity or capability maturity, CMM, than the other group. And those, even though they speak the same language and they both speak the same vocabulary, they still miscommunicate in many, many instances. And it's in product all the way around. So absolutely, I think it's a challenge.
Let's see. What are the best ways to quantify costs associated with poor data quality?
Oh, great topic, and that's the topic of my book coming out this fall called Monetizing Data Management. So I gave you one example here in this that is just one example. There are many, many more. And actually, I think we do a monetizing talk later on this year, don't we, Eileen?
Yeah.
She'll figure when that's going to be. But again, I'll go back to the example here that we had, which was to say that they had a data quality problem. They understood how they were going to have to fix it, and they thought that they were going to spend a lot of time manually fixing it. But hopefully you saw from the example here that we were able to save this particular organization literally millions of dollars and centuries of person work. And that is a very good way to go about doing it. I'll give you another 3-letter acronym to look in there. It's something we found very helpful. It's called activity-based costing. And if that is unfamiliar to you, again, give us a shout. We can give you some white papers and things on that. I think we've got some things. Yes, we did write up some things on this. And again, we'll have a whole book coming out on it in the fall.
Yep, and I checked the webinar is going to be in October.
Thanks, Eileen.
So it might be right before the book is coming out.
Before the good time there.
Yep. Nice.
I'm sure that's not a coincidence. She's expert at what she does.
Let's see. The next question. Analysis, cleansing, enhancement, and monitoring are data quality engineering activities. Which area would you focus on if you were in a small group with an enterprise focus in a large organization that hadn't embraced quality improvements as a whole? Bottom-up approach.
In other words, you haven't gotten the executive mandate in order to do this, and you're trying to figure out how to make a difference to gain executive awareness on this. Claim here that I continue to make, and I have yet to be proven wrong, and that is that I have not found an IT project that has gone bad that didn't have a data quality problem as its root cause. So I would look around at your IT problems and challenges, and hopefully you're not going to tell me that your IT projects go in on time, within budget, with full functionality, because if that does, it knocks it out from under my argument. And I believe that you poke around in there with just a little bit of effort, you will find that the organization has a challenge there. Let me give you an example from a bank that I worked with not too long ago. As in a new system and rolling the new system out, we identified a data quality challenge that was a structural data quality challenge. They were using the wrong structure for a major component of their architecture. And we pointed to them and said, hey, this is a problem. It's not going to work the way you think it's going to work, and we'd recommend that you go live and that you, in fact, fix this particular problem. And they asked us how much it was going to cost, and we gave them an estimate, and they looked at it and said, no, we're going to go live. We don't think it's worth that to fix. Well, we were able to measure the overtime that their people had to put in over the next 18 weeks as they were fixing all of the problems that occurred from our little estimate, and it was clearly 10 times more in this particular instance than the estimate we had to fix the problem doing it correctly. So we could have postponed the go live by a couple of weeks, in some more money, and it would have saved them 18 weeks of pain, and more importantly, 10 times the cost of fixing the error early. So that's a very easy way to take a look at this and figure out exactly what's going on in there. Again, if you look at your IT projects, I think you'll probably find, and let me give you a more quick example here. We're getting close to the end of the session here. I don't know if Shannon can let us extend this or not, because we do have some questions rating still. But one of the other big government systems that we're working with has 3 different ERPs that are being implemented, and each one's being implemented by a different contracting group and coordinating their data. So consequently, we know that these 3 systems will not interoperate, even though they are all the same brand X system. These are kinds of things that we can identify in advance and have happen to them and change again the outcome to a happy outcome in here. Again, if you're working on this area from a bottom-up perspective, get some visibility at the C-level, find out what are the risk areas that people that are keeping people up at night, and see if you can find some way of giving them some insight into how to reduce those risks.
Peter, so it looks like we're right at at least here on the East Coast. So what we'll do is we still have some unanswered questions, but since you all submitted them through the chat, we do have the chat log. So we will write all the questions and include the unanswered ones. I'll make sure that gets you the answer. So you'll have a complete transcript of the Q&A in about 2 business days when we will get you the follow-up materials through Dataversity. So should work out. So thank you everyone for participating in today's event. It was a great ACT session, and we hope you've enjoyed it. Thanks again for Dataversity and Shannon for hosting us. And like I said, yes, you will receive today's materials within the next 2 business days. Just takes us a little time to put it together. Next month, the topic of the webinar is actually we're starting a 3-part series on data systems integration and business value, and the first part of that one will focus on metadata. Hopefully you'll be able to join us for that as well. Feel free to contact us if you have any questions. Thank everyone and have a great day.
Thanks, Shannon.
Thanks, Eileen. Peter, and another great presentation, like you said, Eileen. And just to let everyone know, we do have a new partnership with Morgan Kaufman, so I'll be sure and get you the discount code and the follow-up email as well for Peter's new book. So thanks everyone for attending. Hope everyone has a fantastic day.